All right, problem 5, we have that we're going to consider the differential equation dy over dx equals 1/2 times the sine of pi over 2x times the square root of y plus 7. We're going to let y equals f of x, and it's going to be a particular solution to the differential equation with the initial condition f of 1 equals 2. The function f is defined for all real numbers. A portion of the slope field for the differential equation is given below. Sketch the solution curve through the point 1, 2. Part A. So like just think of it as like like waves, or like just go with the flow of the lines. So the point 1, 2 is here, and so just do your best to follow the path along these slopes. So these little line segments is probably something like this. So you go like this and flatten out, and so something like that, I would say. And part B, write an equation for the line tangent to the solution curve in part A at the point 1, 2. Use the equation to approximate f of point A. Okay, so let's recognize that if we're gonna, I like to still always use the y equals mx plus slope intercept form. I don't know, I just like using it. You don't have to, you can use point slope form, but I'm just gonna use it this way. Anyways, so if we're gonna use this form, let's recognize that the slope is essentially this equation, its function. So to find the slope at this point, we're going to find, essentially the tangent line. We're going to plug 1, 2 into this equation. So then dy dx, when you plug y, let me just write up here, dy dx at 1 at the point 1, 2 will be equal to 1/2 times the sine of pi over 2 times the square root of 2 plus 7, or the square root of 9. Sine of pi over 2 is 1, so it's 1/2 times 1 times 3. So the slope is 3/2. So then I'm going to write that y is 3/2 x plus b. Now we can solve for the y-intercept by just plugging 1 for x and 2 for y. And we would just get that b will be 1/2. So our slope-intercept form of this equation would be y equals 3/2 x plus 0.5. Now, so if we're going to estimate what the value is at 0.8, you simply plug 0.8 into this equation and calculate. So f of 0.8 using this equation will be about 3/2, 1.5 times 0.8. So it's like 1.2 plus 0.7 or plus 0.5. And that would be 1.7. Part C, it is known that the second derivative of f of x is positive on the interval from -1 to 1. Is the approximation found in part B is an overestimation or an underestimation for f of 0.8? Give a reason for your answer. Okay, so if the second derivative is positive, that tells you that the first derivative is increasing. So that means that as we go from -1 to +1, the rate of change of our equation, or I guess our tangent line equations, are going to would be steeper and steeper. So I try to think of this as logic as possible. So if we're using a point at 0.8, then this is going to be an underestimation, because we know that as we go to the right, as x gets bigger, the rate of change is going to grow faster. So this is going to this is actually not going to be the correct this is not going to be the correct slope for values to the right of 0.8. It's going to be smaller than the slopes it's going to be less than the slopes of values to the right. I mean, it's kind of a weird explanation, but the way I would just write it is I would say that, maybe put it simple, underestimation since f prime of x is increasing on this interval. Maybe, let me think of a way to let me look at this picture, I guess, to make it a little more clear. I didn't like my explanation. So let's say at point 8, here's our slope, and we were to, to guess, it's somewhere like here. But if you move to the right, this is actually not the correct, it would, be, this line would be something like this. But where if you move to the right, see how the lines get bigger, get more steep on this interval from up to 1. So see the line is going to be going below that other tangent line. Anyways, so part D, use separation of variables to find y equals f of x, a particular solution to the differential equation dy over dx equals 1/2 times the sine of pi over 2x times the square root of y plus 7 with initial condition f of 1 equals 2. Okay, so for this, I'm going to use a separate sheet of paper so I can write out the work thoroughly, because we don't want to make a mistake. I don't want to make a mistake. So let's start off by multiplying the right by dx, and let's bring the y's to the left. So we'll have the integral on the left as 1 over the square root of y plus 7 dy, and the right side will be the integral of 1/2 times the sine of pi over 2x dx. Now, go from here. So we can use u substitution for each side. On the right side, we'll make the u equal to the y plus 7, and then du will be dy. Then that means on the right side, we'll have u to the negative 1/2 dy. Now on the right side, same idea, we'll just make a v substitution. The v will be pi over 2x, and then dv would have to be then pi over 2. And let's just bring this 1/2 to the outside integral so we don't get it confused with the substitution method, just make our lives easier. So we have dv equal to pi over 2 times dx. Now we only have dx on the right side, so we're going to need to multiply the left side of this by 2 over pi. So we get 2 over pi dv equals dx. Then we set up our integral as 1/2 times the integral of 2 over pi sine of v dv. Then from here, it's easier to integrate using the power rule or reverse power rule on the right. We'll get u to the 1/2 over 1/2, and the right side will go 1/2 times the 2 over pi as our constant. Those 2's will cancel. The antiderivative of the sine of v will be like the negative cosine of v plus our constant. Let's resubstitute u and v for y's and x's. So on the left side, we'll have 2 times the square root of y plus 7 is equal to 1 over pi, or negative, let's put negative 1 over pi times the cosine of pi over 2x. Plus c. Let me write my pi over 2 more cleanly so we don't mix that up. Okay, now we're given the initial condition 1, 2. So this is saying that when x is 1, y is 2. We can plug it in here. We can plug it here, or you can plug it later. It doesn't really matter, but it just depends on like what you feel more comfortable with. So I'm just gonna isolate y first. Well, actually, let me plug it in here so we can make sense of this like both ways. So if we just plug the 2 in for y, we get 2 times the square root of 9 is equal to -1 over pi times the cosine of, and this should be a 2, whoops, I messed that up, times the cosine of 1/2 pi, because x is just 1, so it's just cosine of 1/2 pi plus c. Now the cosine of 1/2 pi is just 0, so this falls away. So then this basically leads to 2 times 3, let's just write this as 6, being equal to our constant, because this is just 0. Now we can rewrite our this expression with the c as 6. So 2 times the square root of y plus 7 is equal to -1 over pi. What is with my pencil? It keeps on breaking. Times the cosine of pi over, this is getting very annoying, pi over 2x plus 6. And now let's just divide both sides by 2 and then square each side, and then subtract 7. So dividing both sides by 2, geez, let me go and use a pen. The square root of y plus 7 equals -1 over 2 pi times the cosine of pi over 2x plus 3, dividing everything by 2, squaring both sides, we get y plus 7. This whole thing squared, and then we just subtract the 7. And we have y is equal to -1 over 2 pi times the cosine of pi over 2x plus 3 all squared minus 7. And that's our solution.